Hello, everyone. So I have been a Scala developer for 8 years now. And right now I can say that I love it. But at the beginning, it wasn't so easy. But there were a couple of ideas which were so good, they kept me going. And one of them was the idea of making illegal states unrepresentable. So this idea that outside there is this chaotic, erratic world, but once the data enters into your system, they're somehow validated, and then with the help of the type system, with the strong type system that we love, it's impossible for some kind of errors to exist. So you have this pristine system when the type system makes sure something is correct. And this is one of the ideas that is very close to my heart. And today I would like to share with you from my project experience how it could be applied and how we applied it in real life to prevent some kind of errors. So for some context, let's imagine that we are working that we are a team responsible within a wider organization for taking care of messaging, for messaging the consumers. So we can send SMS messages, email messages, and push notifications. And whenever some of the other teams, so I will call it domain teams, whether it's payment team, offers team, and so on, whether they need to send some kind of messages, they can just send a REST request to one of our services, and then we take care of the integration with external providers, of saving the templates, because the messages have templates. So there's one template for offers, another template for login authorization, and so on. And we take care of that, and it's the team's responsibility when they need to make some modifications, they go to us, then they send the templates. So it's quite simple, really, and it used to be simple and worked fine at the beginning. But you know how systems evolve? They usually evolve into some kind of chaos. And that's what, after several years, our team found ourselves in. The problem is that the system started to get complex because, as I said, there are many external providers. We sometimes change the provider because of financial or other reasons, or we switch the provider, or we use several ones at once. The API changes. The actual place or database where we store the templates is different depending on whether it's an email notification, email template, or SMS template, and so on. So whenever the domain team wanted to update something in their template, to update the wording, or add a new kind of notification, it turned out that the process was quite long and involved a lot of manual steps. So they told us we would like to make that change, and then we searched and, okay, is it this kind of notification? Then we need to edit some configuration file. Is it another? Then we need to make a change in database, and so on. So it was impossible for the domain teams to do it themselves. And it started to be even too complex for us to get the grasp of how it should be done. And the ownership was unclear. So who is responsible for making sure that the template is correct? Is it us who know about the internals and the external providers? Or is it them who know about the text and the domain and business requirements of the template? So it started to be unclear. But more importantly, we started to make more and more errors. So it happened from time to time that there was, for example, some new notification added, and then 2 weeks later it turned out that it wasn't actually being sent to the users because we forgot something somewhere there in the manual list of steps to update something. So this is the situation where we found ourselves in. And we noticed that, and we thought, okay, that's the end of it. We need to fix it. We need to make it better. So we started an initiative to refactor the state of things that we were responsible for. So we envisioned that in the end of that story, we need a system which would, first of all, be correct. So it would ensure the correctness of the templates. It should have a short feedback loop so that when you are unknowingly introducing an error, you should know it right away and not 2 weeks later in production. It should be simple and clear, so that it's simple to make a change and that it's clear for everybody what kind of template are there now, where you need to make a change, and what is the state. and it should provide the separation of responsibility, so that it's our responsibility to take care of the internals with the internals of the integration with external providers, but it's the responsibility of the domain teams whether the template is correct from the business point of view, because we don't know the domain details of what they are working on. And in all that, we needed a lot more automation so that we don't make so many mistakes. So what we decided to do was to write our own next service, right? So that's what you should do, write something new. But what we wanted to achieve is to hide all the details that the domain teams don't need to know. So they are there where the dragons live. And our new service would be some kind of an adapter or a wrapper with some kind of API or interface for the domain teams to interact with. So as a new service, it was a good opportunity for us to try out Scala free, finally. So we were very happy with that. And we decided to store the templates from the SYAML files in a GitHub repository. So GitHub is something that every developer is quite familiar with. They use it every day. And also every day they use the concept of pull request. So we wanted to use that as well. So when you have a pull request, you can also have some automated checks so that you know straight away if your template is correct. Then you know, okay, you can move on, you can merge it, and then it can live in the system because it's correct. Or you can have this short feedback loop when you know that your template is incorrect and there are some errors you may fix. And with GitHub branch protection rules, you can actually ensure that it's not possible to merge a pull request which is incorrect. So our idea was to make sure that we put as much validation as possible in that initial step of preparing a pull request and then trying to merge it. So how do we envision the templates so that they're simple from the domain team's point of view? The SMS template is the simplest of them all. It just basically has the text, and then it can have some parameters that you fill in at runtime. The push notification template has a bit more fields because it has the heading and the text, and then it can have a link which directs you to a specific place in the app, and then it can have a category. And with the emails, it's a bit different because they're full of HTML and CSS, and they are actually stored on the provider side, but we just need the external ID of the template on the provider, and then we need to be aware of the parameters. So these were the main things that we wanted to model in our domain to make sure this is the correct thing, which only can exist in a correct state. But actually, we decided to add some metadata for it to ensure this separation of responsibility and ownership. So also a template needs to have an owner. It can have several users, so Slack teams or teams in our organization, and some reference. So how we would start with modeling that? If we are using plain types, if we are reading it from YAML files, we would probably have just a bunch of fields where most of them would be strings or optional strings or list of strings. And then we would read it using some kind of decoder. So in our case, Cersei decoder, so that using Cersei parser decode, we can get as a result just two things. Either a correct push template or some kind of Cersei error. And even though it's simple, it already gives us something because for such a simple template, it validates correctly and it's mostly probably okay. And if we miss the heading, then it would be invalid, we would get an error, and that's good because we don't want to be able to merge such a template and then make it flow through our system. But of course, we know that's not enough. For example, what if you do provide the heading, but it's a blank string? You could do it with those simple strings, but that's not what we want, because it would actually be introducing an error, and we might miss it during code review, and it might result in some kind of problem later in production. So here is where the Iron library comes in. It's a library for Scala free, which lets you define so-called refined types. So for example, here we are defining a refined types of the base type, which is a string, refined with a constraint. And our constraint here is that the string cannot be blank. And if we have this, then how would our decoding change? Actually, it doesn't change at all. What you need to do is you add one import. Because what's great about Iron is that it has integrations with many decoding libraries, and Cersei is one of them. So just using one import, we can have the main code just the same. And again, the result can be either a valid push template or a Cersei error. So in this situation, when the heading is blank, it would get returned as a Cersei error. So this goes very smooth with each other. It wouldn't validate, we would get an error, and then we have prevented one kind of error from occurring in our system. So let's see a couple of more improvements that we can do with Iron. So let's look at the reference. This is the reference to some kind of documentation, maybe Jira or Confluence. And if we're using plain strings, then we can merge a template like that. So someone, it's to be defined. They just forgot that they were supposed to provide this link later. And we don't want for such a template to exist in our system because we want the clarity. So what we can do, with plain types, it would validate and we don't want it. What we can do is we can, using Iron, use our type. So we are introducing our type alias, which is, again, what we have seen in the previous slide. It's a base type refined with a constraint. And this is everything we can do because this valid URL constraint comes out of the box in Iron, from Iron, with a couple of other nice constraints that you can use. So if you look inside it at the Iron source code, you will see that it's actually defined like that. So it's this nice long regex, which I'm very grateful I don't have to think of and maintain as part of my code base. I just trust it's there, it has been tested, and it validates what we need. So if we have this kind of validation, if we are using this Iron type, then this wouldn't validate, and it would prevent us from some kind of a mistake. Similar situation we can imagine with the URL, with the link. In the world of push notifications, your notification can direct you to a so-called deep link, so that when your mobile application is registered on your phone with the ACME prefix, then a link like that would redirect you to a specific place of the app, maybe to the statement or maybe to the offers app. So this is how you can specify this link. So if we're using the URL type that we have defined in the previous slide, actually it wouldn't validate. And we don't like it because in our domain it's a correct field. And the reason why it wouldn't validate is it doesn't have the correct scheme, so it doesn't have HTTP or HTTPS. So we need to provide something else. And the way we can define our own constraint using the built-in things from Iron is we can say that this type is either a valid URL or a string matching this regex with the ACME prefix. So you see here the intersection types, which are something new in Scala 3. And here you can use it with Iron. So you are saying it's that type or the other type. So this way you can provide a little bit of more what you need for your specific project. And then this deep link would validate, and that's good. Another improvement that we can make is with categories. So again, you can have several categories for a mobile notification so that you as a user can decide you want to be notified about those, but not about the other ones. And this template may look correct, the default category, but actually it is not. And the reason is that in our system, it turns out we have other strings. We have general or offers category. We don't have the default category. And this is the error that it would be easy to make this error and to miss it during code review. So we want to ensure it with types and with constraints. So what we can do is we can define our push category type. using a constraint again. And here, this is the way that you can define your very own constraints with Iron if there is nothing out of the box that you can use and use the intersections and so on. So you are implementing a type class, but you don't really need to know it's implementing a type class. This is this given keyword, which in Scala 3 replaces the implicit with being much more clear and easier to use. And then you need to implement two methods. One is the test method, which contains how you would want to test whether the constraints should be evaluated to true or not. And you have the message method where you have the text, which is the error that you want to return if the constraint is not followed. So this is all you need to do to define your own constraint. And you will also see this inline keyword, which is another addition to Scala 3. Again, you don't need to know about it, but this is one of the things which Iron uses underneath, apart from other things like opaque types, to provide this kind of validation, both compile time and in runtime. Because here I am showing you mostly runtime validation because we are reading from a file. But the same constraint, if possible, would be evaluated at compile time. So if we have those strong types and then we reassign the values somewhere there and it flows through our system, then Iron will be able to warn you or actually prevent you at compile time from assigning to where it shouldn't be assigned. So, for example, it's not possible maybe to mix the deep link with the URL or with the heading and so on. And using the inline keyword from Scala 3, which guarantees that it will be evaluated at compile time, what follows, means that Iron can do it without the macros. So that's nice. It makes it very lightweight, and it's also very easy to use. So with such a constraint, we can make sure that such template would be incorrect, and then again, you cannot merge the pull request. So we are preventing our users from making another kind of mistake. And there's a very similar situation in our case with the teams. So you have the owner, and this kind of template can look correct. So the owner is the billing team. But we are saying, no, we don't want it to be correct because we want it to be more concrete with Slack handles so that later we can notify the teams whenever there's a change to their template. So again, we implemented it in a similar way. So we have our own type and we define our own constraint. And here it's very similar. So we have the test method, we have the message method, and the test method contains some kind of a list which it checks again against whether it's a correct Slack team or not. And again, this wouldn't validate because it's not a Slack handle, and we're good. But let's take a closer look at this team Slack handles, because we implemented as Scala 3 enums. So that's what I wanted to show you. Because in Scala 2, if you have tried to use enums, you know they're a bit inconvenient, or people probably prefer to use sealed traits and then implement them and so on. So this is a way of doing things, but in Scala 3, the enums have been completely redesigned, and right now they are just everything you would imagine an enum to be. So it can be a very simple enum. So in our case, it could be just the enum with the case, operations, payments, and QA. But if you want, you can extend it with parameters, and this is what we did here. So each enum has the name, the Slack handle, and the Slack ID. So we can use the name where we format our Slack message nicely. We use the Slack ID for the template authors to use it. And then there's Slack ID, the Slack handle is for the templates, and Slack ID is for the actual implementation of the webhook, which sends a message to Slack whenever the template is actually being deployed either to staging or production. So this is something from Scala 3 that is, again, as other Scala 3 improvements, very easy to use, and it makes your developer experience much better. So these are the Iron validations, but there's one thing that we need to notice here. So that when you create templates, then if there is an error, if you are using this the code method, then even if you provide a template like this, which has several problems, you would get just one error. Then you fix the error, you resubmit the template, and then you get the second error. Because what this Cersei decode method does by default is it short circuits on the first problem. And this is not what we want for a good user experience. It's like you are submitting a web form, and maybe there's a problem with the password that you have thought of. Then you want to know all the rules that you didn't provide at once. And for this, what we need to do is we need to use another method, which exists in Cersei. In this case, is this decode accumulating. We can use it, and then the return signature, the return type of the method is different. It's not a template or an error, but it's either a correct template or a list of errors. So this is this validated null from the CATS library, which is very useful here. And this way we ensure good user experience so that if you submit a template, then in your PR, when you have a problem, then you see all the things that you should fix, then you fix it, and you can, once it's validated, you can move on. So this is something important that we did for our users. And also, let's take a look in a bit broader context, because the validations that we have seen here, they were all about the schema. So we just look at the contents of the file. But you can provide more validations if you look in a broader way. So for example, you can ensure that there is some file name convention satisfied here. Because our template service is actually not a real service which is deployed somewhere. It's mostly a GitHub repository with a list of templates collected in some directories. And we don't want it to evolve into chaos. And we would like to enforce a file name convention so that there is some order. So for example, we can say that we want first the notification type as a directory name, then the environment when this should live in, and then the name of the template. So if we add this validation to the pull request validation as well, then we ensure that this can never be chaotic, that this can never change. And similarly, we can think of other validations, like maybe for each production template, there needs to be a staging template first to make sure that things are tested in the correct order and that there are no typos between what we think we are testing and what we are really testing. And validations like that can be added to this validated non-empty list. So to this collection of errors that you may want to have returned at once. So what we can do is we can keep using this validated null, this validated non-empty list. And if we have several methods which do validation, each of them returns this validated null, then what is nice about CATS validated is that you can then compose them. And this way, composing more and more longer lists which contain more of all the errors that you have made. And if you have a method like that, which again returns a validated null, then you can decide what to do. Because at the end, you will have either a list of the templates and the changes that you have made correctly, or a list of problems. And you want to display this whole list of problems to the user, fail the pull request, and be sure that none of these errors occur. So in the end, with the heavy use of Iron, we have achieved our dream. We did the refactoring. It took us a bit longer than expected, but it's finally there since a couple of months. We are very happy with that. It gives us all the things that we wanted. So that's correctness, that's short feedback loop within this first step of submitting a template. It's simple and clear, both for the domain teams and also for us, because we have hidden all the complexity somewhere there, providing some REST endpoints to interact with the chaos and complexity, which is still there, but it's hidden. It's not exposed to the end user who doesn't need to know about it. And we have enabled the domain teams to take full responsibility of the correctness, of the business correctness of the templates. They do use it, they do submit the pull requests, they invite their colleagues to provide review for this pull requests, and it's already automated. And since the introduction of them, we haven't had a single production incident related to missing template or missing parameter or things like that. What we have used is Scala Free and Iron, and in my opinion, it worked really well. So in Scala Free, what we have seen in this presentation are the givens, so not implicits, but simpler syntax for givens, which we use when implementing Iron methods. We have seen the inline keyword, which lets Iron do its stuff in compile time without the macros. We have seen the union types, and similarly, there are intersection types, so we can say that something is both of this type and of the other type. And the enums, which can be as simple or as sophisticated as you want. In Iron, you would use mostly the built-in constraints. There are many useful ones, but you can also define custom constraints, as I have shown you. The important thing to remember is that Iron validates the constraints both in compile time, if possible, and in runtime. And in our case, this integration with Cersei was something that we really welcomed, because that's something we work with anyway. So it was a very smooth experience altogether. And one last thing you may ask is, could we have achieved the same thing in Scala 2? And the answer is yes, we probably could. Because there is this refined library that we have seen in the first talk actually today. This refined library in Scala 2 gives you mostly the same functionality. So it gives you refined types, it gives you validations, but it exists only for Scala 2, and it uses shapeless and macros underneath. And Iron exists only for Scala 3 because it uses this advanced type system changes. So the decision which to use really is quite simple, depending on the Scala version that you use. So overall, we are very happy with that. So I wanted to share with you that such things can be done, that you can, of course, you know that you can refactor and re-implement the processes that you have in our system, but there are also the tools which can make that better and which can save a bit of your time. Thank you. If you have any feedback, I would welcome them under this QR code, and there's also a link to the slides.